Welcome to the NumPy part 1 tutorial. So my name is Robin, and in this video I want to walk you through the basics of NumPy. So in this video I will be teaching you how to convert the Python data structures to NumPy and creating an array using arrange functions, and discuss about linear space, zeros and ones, and discuss about multi-dimensional arrays. So if you have never heard about NumPy before, this is basically a numerical computing library in Python. If you are trying to learn machine learning, data science and so on, you cannot miss this library. So let's get started. So the first thing I want to tell you, because before getting started, is please subscribe to my channel, because you don't want to miss the part 2 and other machine learning and data science videos that I am going to upload soon. So please subscribe to my channel. Your subscription and likes help me a lot, so please like, comment, share, subscribe, do all those good stuffs for me, so that I can just be motivated to and work about this, and I'll be just producing more videos about NumPy and just machine learning and so on. So let's get started. So the first thing you want to do to use this library is import it. So we have imported this library and namespaced it as np. The np namespace is using because we want to use np as an alias, so that we won't have to write numpy time and again when we are going to use this library. So we have imported and namespaced it. Second thing I am going to teach you is to check the version of NumPy you are using. So you can use the Python print function here. So use the Python print function, and as we have already namespaced NumPy as np, so write np dot and write two underscores and version and in with two underscore, and just press shift and enter, and it basically returns the version of NumPy that you are using. So the second thing I want to show you is how to convert the ordinary Python list into the NumPy array. So let's see, we have created my list here, and this is basically a simple Python list. So Python list are just nothing but the elements inside this square bracket. So I want to convert this into the NumPy array. So there is a function called array here in the NumPy library, so you can make a use of that. So I have put this NumPy array into the my array variable here, and my array variable equal to, and you can put this my list as the parameter here. You can pass this as the parameter. So and you can see this list has been converted into the array. So you can see here the one is there small bracket and another is a square bracket. So you can see this has been converted, this list has been converted to the NumPy array. So the another thing I want to show you is why do we actually need these NumPy arrays. So as you can see here, let me first comment this out and press shift plus enter to execute this cell. So I have a list here, my list here, and I have used the multiplication operator and 3 here. So when I have executed this cell here, so it has replicated this list 3 times. So this is not what we want, right? What we want was here 9 and 4 into 3 and 5 into 3 and so on. We want actually a vector multiplication in this. So the downside of list is that it replicates while using these operators. So I want to comment this out. So and enter here, shift plus enter. So you can see here the vector multiplication has been successfully done by the NumPy array. So the next thing I want to teach you is how to convert tuple into the NumPy array. So I have created a tuple that contains integer, floating point and the complex data type. So I have converted this the same way as before using the dot array method here. I have passed the tuple as the parameter and I have printed this array. So let's say shift plus enter here to execute this cell. So one thing to notice here is the 14 has been complete, it has been promoted to the higher data type in the tuple, so it has been converted to the complex data types. The same thing goes here, so the same thing goes here. So the one thing to notice is the NumPy data type. The NumPy only works with one data type, so it has been converted to the higher data type. So the another thing I want to show you is how to create array using the arrange function. So I have already namespaced as numpy as np, so I want to call the arrange function with an integer parameter. Here I have a parameter 4 in here. Let's execute this cell. So it has created the 4 elements in the array, so basically starting with 0 and ending with this element -1. So in this, the stop parameter is mandatory. So as you can see here, we have passed the stop parameter 4 here, and it has just stop in there. So the another thing I want to show you is the start parameter and stop parameter. So you can call the arrange with this, so it will basically start with this and end with this. You can show you is how to check the length of this numpy array. So you can see here the length is 60, so 40 to 100 is 60 using the length function of the Python. So the next thing you can do to achieve the same is just use the cipher, and you can get this here. 2 to 8 is 2 to 10 is 8. So you can, the next thing I want to show you is to use the step size. You can use the arrange function with the step size, so starting from 10 ending in 34 and step size of 5. Press shift plus enter. You can see here 10, 15 and so on, just with step size 5. So now I want to talk about these 3 important functions in the NumPy library here. The first one is linspace. This is very one of the important functions in NumPy. So you can see here the documentation says that it returns evenly spaced number over the specified interval. So let's check if that is true. So I have also written some important things about it. So for using the linspace method, you need to specify the start and end parameter, that is mandatory. So we have also specified the another parameter 9 here. So this 9 parameter, basically it returns the 9 values in an array. So let's check this. So press shift plus enter. Here you can see here from 5 to 15 it has printed the 9, it has output the 9 element into the array. So the one thing to notice here is that linspace is closed interval. So the closed intervals mean it has also included the first element here, and also it has included the last element, the 15 here. So it has included the 15 here. So notice that the 9 is not the last element here, and it is the count that we are wanting from this array. So the next thing you can do with this is you can also, I have just put this function into the variable here, this into the variable, and called the numpy function linspace, and I have specified the 3 parameter start, stop, and the number of arrays, the number of values that we want. And I have also send the another parameter here, return step equal to true. So this basically returns the step size between these element of the array. So if I execute this, let's see, shift plus enter. So you can see here we have 2 parameters in this array. So the first one is the array itself. So the first one is the linear spaced array itself, and the second one is the step size. So you can access this step size by using the 0 indexed array. So I have kept this into this variable, and this is basically 0 index and this is 1 index. You can see here comma. So if I access this with this 1 index, you can see the step size of this linear spaced array over the closed interval is 1.25. Yes, that is true. 5 to 6.5 and so on. So the next thing I want to show you is how to use the zeros method. So the zeros method is used to create the array of zeros. So if I execute this, you can see here there are like 5 zeros in here. So one thing to notice here is that all of these are in floating point. If you want to specify a different type of data, so you can do is d type equals to, I want this in integer, so I want to say it is in integer and 64 bits. So press shift plus enter. Here you can see here it has changed to the integer type. So there are many different types of data type, basically integer, floating, complex, and boolean, and unsigned. So you can read more about what type of data are supported in this here. I'll post the link to this in the description below, so don't worry about it. So the next thing I want to show you is the ones method. This basically works the same way as zeros. You can also specify the data type for what type of data you want. So it has also returned into the floating type, so that is very easy. So The next thing I want to show you is how to create the multi-dimensional array. So here I want to create the multi-dimensional array of 4 and 4 columns, and I have specified this inside the zeros function in the tuple. So notice that here are two small brackets and you need to specify the row and column inside the tuple. So if I execute this, you can see here we have a matrix that contains 5 row and 4 columns, 5 row and 4 columns. So you can also create the 3 by 3 matrix here. So if I execute this, so you can see here this means that we have 5 group of matrices. This 5 means we have 1 2 3 4 5 group of matrices, each of 4 row and 3 column, 4 row and 3 column, 5 group of matrices, 4 row and 3 column. You get that, right? So here is the same thing has happened. It has been printed in the floated format. So if you want to print this in integer, or if you want this in integer, then you can just specify the data type here. The type equal to here. You can also use another type of data, as I have already told you. You can just check this out. So the last one I want to show you is the same thing, the ones here. If you want to print the ones in integer, you can do like this. So thanks for watching, guys. Don't forget to subscribe, like, comment and share. There is also the part 2 of NumPy tutorial that is going to come out soon, so stay tuned. You need to just subscribe for that, because you won't know when I'll be just posting it into the YouTube. So don't forget to subscribe and